Assalamualaikum warahmatullahi wabarakatuh. My name Nur Hidayah binti Asa. My student ID is 2021373245. Okay, now I will do the micro-teaching assignments. I'm currently teaching at SMK Tasisi Convent in Ipoh Perak, and I'm teaching mathematics subjects. Okay, now let's go. Assalamualaikum warahmatullahi wabarakatuh, and good morning everyone. Okay, good. Sit down. How are you today? Irma, are you feeling good? Yes? Alright, Alhamdulillah. Okay, girls, have you having breakfast this morning? Yes? Yes? No? No? Some of you said no. No wonder I see some of you feel less energetic today. So I think I want to do something with you guys. Alright? Okay, everybody stand up. Okay, faster. We will make it quick. Alright, good. We will dancing this morning to fresh your mind. Okay, I will turn on the music later and you must copy my dance, alright? Okay, this exercise was very hype in my school long time ago. So we'll make it now. Okay, before that, the student at the back, can you see me in front? Okay, good. If you don't see me, you can come in front, alright? Okay, I will turn on the music. Okay, finish. Alright. Okay, everybody. I want you to take deep breaths 3 times. Alright. Okay, everybody. Do you feel warm and sweat? Okay. I feel good right now. Yes? Okay, I can see some of you feel very energetic today. It's a good improvement. Okay, now I want everybody take a deep breath 3 times in my counting. 1, 2, 3. Hold up for 5 seconds. Exhale. Alhamdulillah. Okay, do you smell the food smell at the canteen? Yes. Okay, later you will rest, okay, after this subject. Okay, now I can see your face is more energetic and more cheerful. It's okay. Now everybody can sit down. Okay, you may drink some water if you feel tired. Alright. Okay, students, I want to ask you guys what we have learned yesterday. Who knows? Yes, Aminah? Very good. Okay, Aminah said that we learned about distance time graph. Now, I want to ask you guys, the gradient of distance time graph is carry out a new unit of motion. What is that? Okay, stand up, Juliza. Alright, good. The student at the behind, can you hear what Juliza said? No? Alright, it's okay. I will explain. Juliza said the gradient of the distance time graph is velocity. Do you agree with that? Yes. Alright, it's a correct answer. As for today, open your textbook, turn to page 195. Who forgot to bring the textbook? you can share with your friend beside you, okay? But don't forget, after this you must bring, okay? Alright, Alhamdulillah. Okay, today we're gonna learn about speed time graph, or the synonym is velocity time graph. Before that, I want to show you one video related about this topic. Okay, now let's watch the video. Okay students, we have finished watching this video. Now I want to know what you can see in that video. Anyone? Yes. In the video, who is the winner? Who knows? Yes, the red F1. As we can see, the red F1 shows all of the cars in front of him, right? Okay. What Miss Yu want to highlight in this video is the pedometer. Who want to tell to our class what the function of pedometer? Yes, Fatima, what is it? Yes, absolutely correct. Fatima said it is for measure our speed. As we can see, when the pedometer is show 92 km per hour constantly, what happened to the car? Yes, good. Speed of the car is constant. Then, when the right car bypass the red car, then the red car is chasing back the white car. What happened to the pedometer or the speed? Yes, correct. The speed is increasing. This is because the car was accelerated to chase back the YF1. Alright. Who noticed when the red F1 deaccelerate? Alright, brilliant Zahra. Zahra said when the F1 was at the corner. As we can see at the corner, the pedometer is decreasing to slow down the car. It is for precaution to avoid the accident at the corner. Alright, last one. I want to ask the student at the back. Soraya, beside Soraya, stand up. Alright, Fareha, my question to you is, when the pedometer is showing 0 km/h, what does it mean, or what happened to the car? Yes, correct, good. Fareha said the car is not moved. Okay, fortunately, Fareha can answer this question. After this, Fareha and Soraya, please focus on in class, okay? Okay, good. Teacher is not angry. Teacher just advise. Alright. Okay, never mind. With the video, we can see the relationship between the speed and the acceleration, right? Alright, the relationship is when the speed is increasing, then the acceleration also increase. But when the speed of the car is decreasing, so the acceleration also decreasing, or the car is decelerating. Alright, everybody can understand this relationship? Okay, the rest, do you understand? Alright, Alhamdulillah. If you don't understand, you just can ask me, okay? I will make it clear for you. Okay, students, now look at the graph in the textbook, page 195. There is one linear on the graph, if you can see, right? Okay, to make it clear, I will transfer the graph into the bigger size on this whiteboard, okay? Okay, this is the speed. And then it is m square or some of also can write like this. So okay, it is as it is the time. The unit time is second. And this is the linear. This is the linear going up. With 2 part, like this one. This one is s2, y2, and this I think it is s1, y1. Okay. You guys also can copy this one. Okay. What is the important thing we need to know about this graph is we must draw the two axes and also the origin. The axis, the horizontal line or this x-axis represent the time in second, and also the vertical line or the y-axis represent the speed. The unit of speed is meter per second, or you can also write like this. Okay, the gradient of the graph represent the rate of change of speed with respect of time, which means acceleration, or in Malay is perjutan. Okay, the area under the graph, okay, I will sketch. Let's see. Okay, the area under the graph, so this area is the distance traveled by the motion or by the object. Okay, so far, do you clear? Okay, Alhamdulillah. First, how the gradient be the acceleration? Who is wondering? Okay, I think all of you are wondering, right? Okay, let me show the detail. Okay, first I will draw another graph here. This time you must copy my sketch, okay? My explanation. Because this is important to you. Because I want to tell where we can get the acceleration from the gradient, and also how we get the distance by using the area under the graph. Okay, this is the speed and s, m, s, 1, and this is the origin, and this is the time in unit s. So this is one line going up, reflect, and down. Sorry, my explanation not very good, but it's not okay. Okay, I will make the point here, and here. Here is from u, and this is v. V is 0, 6, u is 0, 4, 0, and this is, as you can see, is adjacent. So this is point q, p, q, r, s. Okay, touch the horizontal line. Okay, so this is 3, 6, the coordinate is 3, 6, and the coordinate of r is 5, 6, the coordinate of s is 6, 0, okay, 6, 0. Now, as we can see, the PQ, the line PQ, this line is increasing from U to V. Okay, so when this is going up, so there is a change in speed, right? Because from 4 to 6. If there is a change in speed, means there is an acceleration. So how we can calculate the acceleration using the gradient or slope? Okay, we can calculate it by this formula. Rate of change of speed, or also you can write it as acceleration in the unit of A. The formula is like this: y2 minus y1 over s2 minus s1. Okay, this gradient we have learned in form 3, right? And form 4 also we learn. So I will calculate it. y2 minus y1, the formula, x2 minus s1. So the upper part is, the y2 is 6 minus y1 4, and also this s2 is 3, also s1 is 0. So can you calculate for me? Alright, good. It is 2 over 3 m s negative 2, or m over s squared. Okay, it is the same meaning. Okay. Do you understand why we can get this 2 over 3? Okay, good. Alhamdulillah. Alright. Okay, as we can see, the line Q until R is a straight line in the adjacent to the horizontal axis. So the speed is constant because from Q the speed is 6, and from until R the speed also 6, as you can see, right? Okay, so from Q to R the speed is constant. The object is moved at the uniform speed. So if there is a uniform speed, so there is no change in speed, right? If don't have any changes in speed, so the acceleration exists or not? Yes, good. There is no acceleration at all. So we can assume that if the zero in aggregate, okay, yeah, equal to zero acceleration. Okay, who are still like blur, or you want me to make it clear? Yes? Yes, Zara? Okay, you want to me to explain why it can be 0? Alright. Okay, to prove that, we show A equals to, like y2 is 6, y1 is 6 over x2 is 5, and this x1 is 3. So 0 over 2, 0. Okay, so there is no acceleration at all. Okay, how we can know which coordinate is x2, and which coordinate is x1, y1? Okay, so now we take the before and after. So this line is from Q to R. So which is the starting point? Yes, Q. The starting point is Q. So the last point is R. So we take the last point as the x2, y2, and the starting point is x1, y1. Okay, do you clear? Alhamdulillah, good. Okay, last one. We will calculate the acceleration of RS. Since you can see this RS is the speed is going down from 6 to 0. So this is having, the motion is having deceleration. Okay, I will write to make it clear. From RS, the speed is decreasing, hence the rate of change in speed is negative. So, since the rate of change of the object is negative, the motion of the object having the acceleration. The acceleration means in Malay is nyah pacutan. Okay, the object is the acceleration. Alright. Okay, but to prove it, some of us like not see why it is negative, so we calculate it with the slope or gradient formula. So the acceleration A 0 minus 6 over 6 minus 5 equals to negative 6 over 1 equal to negative 6 and plus negative 2. Alright, do you understand why it is be negative? Yes, Alhamdulillah. Okay, this is because the 0 minus 6 is negative 6, right? Because this is final point. So this is the final point is S, not R. Don't change R minus S, okay? Because we want to know from R to S. So it means S minus coordinate S minus coordinate R. Alright? Do you clear? The person at the behind, can you see? Okay, good. Alhamdulillah. Okay. How the gradient or the slope be the acceleration, and how the area under the graph be the distance traveled? Okay, we can see that throughout the unit that we use. Okay, for example, I will show you the acceleration first. Is in unit meter as negative 2. It is the same meaning. So, if we divide the speed divided by time, like we just use just now, like apa? At y2 minus y1 is the speed, right? So this S2 minus S1 is the time. So we can simplify it to the speed over time. So ms over m over s over the time in unit s. So if we can see this term, so s, this s is over 1 actually. Okay, the ink is running out. Is 1. So it will be like this. To transfer the divide be the multiply, we can change the place upside and down, right? So times 1 over s. So what it will be? Yes, good. M s square, because s times s is s square. Alright, so this is the unit of acceleration, right? Right, clear? Okay, that's how we get the slope by using the formula. Alright, the second one, I want to show how the area under the graph be the distance using the unit. Okay, for distance, m. So we calculate the area, right? So when we calculate the area, we must times both of horizontal line and the vertical line to get the area, right? Like this, 1/2 times as example times 10 times 6. So we assume that 10, this 10 is the time and this 6 is the speed. So the m as the speed times the time equals to m. Why? Because this can be cancelled, right? Do you agree? Yes, like this we can get the distance from the area under the graph. No matter how shape is it is like this is trapezium and this is like rectangular, and this is also the trapezium. See. So we can get all the area under the graph is the distance travelled by the motion or by the object. Okay, do you clear? Okay, if you have any question, you can ask me or interrupt me, okay? I don't like if you keep the question in your mind. You will not understand what I say after that. So if you have any question, just ask me or just raise up your hand, say, Miss Yu, I want to ask. Okay, Miss Yu, I don't understand. Miss Yu, please clarify more. I'm okay. Okay? Alright, Alhamdulillah. If you understand, I want to show you an example. So far, do you understand the concept? Sure? Sure? Fatima, sure? Zara? Aini, sure? Amira, sure? Alright, good. Okay, I want to proceed to the exercise, okay? Look at the example 1.4 in your textbook, page 201. Okay, look at the graph. You guys can do the exercise or the example. Later, we will discuss. Okay, thank you, Soraya, Hazika, and Jazila answer this question. So the rest is your answer is same as them. Okay, this for A is 4 ms negative 2 and B and C is 600 meter. No? Okay, some of you know since okay, this is the correct answer. Since some of you is not getting the same answer, I will explain to you how they get. Okay? Okay, for the first question, calculate the rate of change of speed in ms for the first 5 seconds. So, for the 5 seconds is from this initial point, the origin, until this 5 second time. Okay, so the motion that we want to calculate is this line from this point at 20 and this point at 5 and 40. So I will label the coordinate first. Okay, the coordinate is 5, 40, and this is 0, 20. So the rate of change of speed or the is denominated with acceleration is the change of speed and over the change in time. So y2 minus y1 over s2 minus s1. This is the formula of gradient. So the y2 is 40 minus y1 20 over s2 5 and s1 is 10. So the answer is 4 ms negative 2. Okay, clear? Okay, alhamdulillah. Okay, then the question B asks, describe the motion of the car. The car moves at a uniform speed of 40 ms negative 1 for the period of 5 seconds. If the question asks to describe the motion, so we need to state the speed, but when the The question asks to describe the speed, so we must state the acceleration, whether it accelerates or decelerates with what you need. As example, I want to explain this question A. So the explanation is like the car accelerates 4 ms negative 2 for the period of 5 seconds. Or if it is constant from I want to explain this line, so it will be the car is 0 accelerate for the 5 until 10 seconds because the speed is constant. Okay, if we want to explain this, is same like this, okay, because both are accelerate, but if it is deaccelerate, just you just say like this, the car deaccelerates how many you need from the period of what second, or from what until what second. Okay, do you understand? Okay, good. Okay, so the C, calculate the total distance in meter traveled in the period of 15 seconds. So the total distance traveled, let's say, is area under the graph. So area under the graph, we can see this is including three area. Area A, this area A, B, and C. So it including two trapezium, rectangle, and trapezium. So how your friend get 600 meter? So they use the trapezium formula, which is formula 1/2 times b times height 1 plus height 2. Okay, this height is height 1 and height 2. So in 1 height 1, that's h2. Like we have familiar with this formula, right? Since 40 2. So it's easy. So rectangular. Rectangle. What's that class? Okay, good. B times h. So I will draw to make it clear. You can take out the shape from this graph outside the graph. Okay, you draw back the shape like I do right now. I want to draw the trapezium A. Okay, the trapezium A is, this is from 0 to 5, so this is 5. The base is 5. So this height is from 0 to 40. We look at the vertical line. So from 0 to 40 is 40. So what is this height? Okay, good. 20. Okay. So we move to the rectangle B. Rectangle B, 5, also 5 because 10 and 10 minus 5, 5. And this is 40. 40, both sides 40. Then last one is the okay. Okay, here is the another trapezium C with the base 5 also, and the height h1. This coordinate is 15, 16. So where is the height? Okay, 60. Good. And the other one, other side is 40, right? Okay, so that's how they come to this. So this is for trapezium A. 1/2 times the base 5, bracket 20 plus 40 plus the rectangle B, 5 times 40 plus the trapezium C, 1/2 times base 5 times the both height 40 plus 16. So it will get 150 plus 200 plus 250. So the answer is 600 meter. Do you clear? Okay, anyone want to ask me before we end our class for today? Okay, everybody is clear? Okay, since nobody asked me, so I think that is for today class. I will leave you with some exercise. Please look at the page 205. Please do the exercise 1, 2, 3, 4, and 5. Tomorrow 8 a.m. sharp. All of your book must on my table, okay? Okay, monitor, please collect the book tomorrow, okay? Don't forget. Alright, thank you. Okay, thank you. Assalamualaikum warahmatullahi wabarakatuh.